Okay. Tēnā koutou, katoa, greetings everyone. I'm Joanna Santa Barbara, the co-chair of the Nelson Tasman Climate Forum, which is sponsoring this webinar. The Climate Forum, I'll say a couple of words about it before introducing Mike. The Climate Forum is a big tent for individuals and organizations working to bring people together to work on urgent climate action, mitigation, adaptation, and doing those in ways that take care of all species, including humans now and in the future. And today is very close to the second anniversary of the Climate Forum. So let me use this occasion to salute the participants here tonight who founded the forum 2 years ago. And I hope you'll feel a surge of pride in what it has achieved so far. I'll say a couple of things about the tech of tonight's talk. First, to note that it is being recorded and will subsequently be available on the Nelson Tasman Climate Forum website. And I'm sure will be much used after this event. Mike will talk to us for a while, and then you'll have an opportunity to put questions to him. And we'll proceed for as long as questions are flowing up to finally 9:30. We may end before then, but we can go up to 9:30 thanks to Mike's generosity. To ask questions, we ask you to use the Q&A function. Try to avoid using the chat function for that. Use Q&A, and also not raising your hand, as it will be easier if we've got the questions all on the Q&A list. You do have the option of looking at other people's questions and upvoting those questions. If you see one that you especially would like to have answered, you can upvote it. One more thing. At the end, when you exit, when you leave the site, there is a survey which we would rather appreciate your filling in. It's very brief and it will be of assistance to us. So now let me turn to introducing Mike, our very valued guest. Last November at a forum hui, one of our members, the much loved Shappy, Ian Shapcott, and Bill Rees of Ecological Footprint fame, discussed with us the concept of human ecological overshoot. And to put it in Shappy's inimitable succinctness, too many people behaving badly on the planet. Seeing this as fundamental to understanding climate change, loss of biodiversity, damage to biodiversity, and other ills of the outsized human impact on the planet. Many of us have been wrestling with the implications of that understanding. What does this mean for our energy systems? What does it mean for our food systems? And we decided to ask our favorite iconoclast, did I say iconoclast? I should have said ecologist, our iconoclastic ecologist, to help us think through this, Dr. Mike Joy. Mike Joy is New Zealand's best known ecologist and has been very, very much awarded for both his ecological expertise and also for his courageous outspokenness on what we're doing to our environment in New Zealand. Fresh water is Mike's home discipline, but Mike's thinking and speaking ranges far wider than that. He's fearlessly outspoken in ways that we all might aspire to. We who are working to protect and restore the natural world, our only home, have some tough thinking to do on the nature of our tasks. We very much look forward, Mike, to your input to assist us in this thinking. Over to you, Mike.
Thanks, thanks, Joanna. It's really nice to be invited to do this. You and Jack are both very inspirational for me, and I think that it's you know, we're part of a small club, and by the look of the number of people that are, you know, attending tonight, then maybe the club's getting a bit bigger, of people who understand and want to know about these kind of things, because knowing it can be a bit uncomfortable. I did want to mention that going from freshwater and then into energy is a progression that I've been going along for a while, but I think hopefully you'll see through my talk that how they are interlinked, very much interlinked. When we look to the future, food and energy can't be disconnected, because they are dependent now on our current systems. And so I'm going into a tricky place, I guess. It's always difficult when you're an academic to be going outside of your area of expertise, and it's frowned upon by some, but I think it's the most crucial thing, is that the ability to be able to connect up all of the dots, and people who can think across all these spaces are going to be the people that we need in the future. The kind of reductionism and specialization of academia and science is not helping us kind of get through these problems. So anyway, I'll rip into this, and hopefully I'll try not to confuse everyone too much, and we've got plenty of time for questions, so I can kind of fix up this if I skip through things that I assume that people know. Knowing that many of you have seen Bill Rees and Shappy's presentations, I know that you will have some background in this stuff. I think this little bit that I put in the slide here about us not trying to comfort politicians, and there's this really big problem where politicians, they pretty much want to, they say what they think people want to hear. The people that work for them in the government departments are always trying to say what they think the politician wants to hear. So we get this kind of, it's almost like Chinese whispers, where the raw information is very much adulterated by the time it gets to the politicians, and then the politicians play another form of Chinese whispers to make sure that the public don't know the reality either, because they will tend to not vote for them if they don't say positive things. So I think that's this word reality is something that I keep banging on about, and turns up in so many things. I'm sure that you're all aware of the limits to growth stuff, and what I'm talking about tonight is really about the limits to growth and how we've exceeded them, and how that is going to impact the future. And so we have these models from 1972 coming out of that work with the MIT students and the Club of Rome funding this stuff, and then this very recent update, this woman who's high up in KPMG, Gaia Harrington, who worked on this, and shows that those predictions from the 70s are actually bang on. And this is, to me, this is really something when I would imagine is quite a conservative organization, KPMG, starts, having somebody high up in the organization who understands this stuff and writes about it. The word should soon be getting out. Okay, so what I'm going to do is going to give you concentrate on New Zealand for a start, and with freshwater, but global examples of the biophysical realities that are the overshoot of those planetary boundaries. And the planetary boundaries are kind of the Rockstrom Institute's modeling, and that's showing how far we've exceeded the limits of the planet to support us, and relate that to food production. the reality of this switch that we've had that is so fundamental to how we live, that the food that we eat, instead of going out and gathering food because we need energy to stay alive and getting more energy out of it than we put in, which is key to our survival as animals on this planet, how we flip that and we now have net energy negative food. It'll touch on energy density and its consequences, because I think it's really important to understand, and there's a lot of kind of ignorance around energy. About this transition away from fossil fuels, I want to sort of talk about the fairy tales of renewable energy that are being thrown around a lot at the moment. And I'm mainly concerned, I'm okay with fairy tales, but when the fairy tale means that people believe that they don't have to do anything because this magic renewable, we'll just be able to stop using fossil fuels and we'll use renewable energy instead. The fake news around that means that people don't see the urgency of change, and that's why I don't like these fairy tales. And I'll touch on how we can produce food in the future in a sustainable way that we can survive longer on the planet. So there's so many warnings now. Just the IPCC report out the other day after day, there's just more of these reports that if the world doesn't act soon, there'll be catastrophic biodiversity loss, untold amounts of human misery. We keep getting these warnings. Every graph that you look at shows that we're in trouble, and there's just multiple websites that have this information. It's easy to find. It's happened really, really recently. I mean, in geological time, but yeah, since I've been on the planet, actually, it's my fault. The last 60 years has been the worst, and just accelerating every year. And you starting to get some pretty, vocal scientists now who are really starting to rip their hair out and write papers that you would never have imagined that these academics would have written a few years ago. This, things like ghastly futures. So I think, the warnings are just getting more and more shrill all the time. I'm going to talk about food because we have this problem of a burgeoning population, and another 80 million people to feed every year, and just this one little planet that we're stuck with that hasn't got any bigger over that time, and we have declining amount and quality of land, so we're losing land because we're destroying the land. We're declining. Fossil fuels have peaked, and we can't use them. Energy return on energy invested, I'll just refer to it as EROI, E-R-O-I, and I'll touch more on that. We've got declining water quality, we've got some massive biodiversity losses happening, an extinction phase that is more extreme than any other time, and the decline of wild fisheries as well. And then we add climate change, and then things like antibiotic resistance and much, much more to that. So that we're going to somehow declining, all these things are declining, and yet we have more mouths to feed all the time, and increasing numbers of animal products and fossil fuels involved in that whole, the food that we do eat, and increasing wastage as well. So we have this perfect storm that is predicted to growth. And I'll just touch on New Zealand freshwater, I guess, first, or New Zealand environment. So I've used this slide a fair few times, and maybe some of you will have seen it before, but this is ranking countries in the world on their environmental performance. So the relative environmental impact of countries. And there's New Zealand on the map there at 18. That is not 18 from the best, that is 18 from the worst of 180 countries in the world. This paper came out in 2010, it'll be worse now. So that's absolute rank, 18th from the bottom. Per capita, we're still 45th or something from the bottom. We're 160 out of 180 countries when it comes to per capita. So, it's just a complete failure to protect the environment in New Zealand, and it's it is really sad, given that it's happened so quickly here. We had such, the glass was really full here. We had the best to start off with, so we've done an incredible amount of damage in a very short time to get to this point. This is kind of this gives you an idea of what's causing the problem. So most of you will know, looking at this map, where these red parts are. So the red parts are the worst, the most severely polluted. Red and orange are the moderately or severely polluted. They're rivers. I know it shows up as colors, but they're actually individual rivers on this map. 3/4 of our native fish are threatened, and our crayfish and freshwater mussel as well. Officially 44%, and that was 10 years ago now. The new study, Lakes 380, will know a lot more about how many are officially polluted now, but at least 44% of them, and they're nearly all in lowland areas, are polluted. 85% of the waterways and pasture catchments exceed the nitrate guideline values. 62% of our rivers are unsafe to swim in. And you just say that, here's a bunch of water quality measures, and you can see they're almost identical. The same areas, the intensively farmed and peopled parts of New Zealand are where these problems are with our rivers. And it's because of a bunch of problems, but the recent ones are the addition of nitrates. So the nitrogen fertilizer, and you can see on the map on the left, I don't know what that color is, reddy browny color is the rivers that don't meet the guideline value for nitrate in rivers, and you can see quite clearly the intensively farmed, or flip it, and the only bits that aren't polluted are is the conservation estate. And then you look at the map on the right, and all those red and orangey dots are the ones that are getting worse. And you look in areas like Canterbury that are really intensively farmed, and you've had a 250% increase in the nitrogen load in those rivers. To put it in a global context here, these are some of the worst rivers in New Zealand, in the world for nitrogen flux in the rivers. I've pulled some data from around the world. You can see the Yangtze and the yellow, the rivers in China that are really bad. And then you get a bunch of New Zealand rivers, the Selwyn River in Canterbury, Ashburton, Manawatu, then Korea, then the Waikato River. And then you start getting into some of the, really polluted rivers, like the, known as polluted, like the Mississippi River and the Thames. And they're actually in better condition when it comes to nitrate. So since 1990 is when this has really happened. So 1,300% in the emissions, greenhouse gas emissions from synthetic fertilizer, 660% increase in the fertilizer use over that time. And so, about 80% of the emissions that come from nitrogen are coming from agricultural soils. And the latest big study on our rivers said quite clearly the greatest negative impact on water quality is high producing pastures. That is intensive farming, is what it's all about, high densities of livestock. And the reason we have the high densities, or what allows us to have such high densities, is the amount of fertilizer that's put on it. And it's not just ecosystems and freshwater biodiversity and oceans and lakes and estuaries that are impacted. Also, it turns out that human health is affected by nitrate in drinking water as well. So I've been part of a big study looking at the level of nitrogen in our drinking water. There's a bunch of things like preterm birth defects, and then there's the cancers, the colon cancer, colorectal cancer, thyroid cancer, kidney cancer, and bladder cancer. And so we just did this for the first time, and anyone's really pulled this data together for all of the registered water supplies in New Zealand, which is about 4 million New Zealanders, 4 of the 5 million that we have data for. About 800,000 New Zealanders receive drinking water with nitrate levels above this magic number, 1 milligram per litre, which is above the level where you have increased risk of colorectal cancer. And we've got some more research coming out on that as well. And then to give you an idea of the scale, we've got another paper coming out with this in it. There's a lot of talk about how we need to reduce farming intensity and councils are, starting to talk the talk on this now. And they start talking about how they could reduce nitrogen loss by up to 20%. Well, we've done the sums for Canterbury, and to meet those standards, to give a chance of having healthy fresh water and rivers there, is a minimum 12-fold reduction in farming intensity. So this is, this is basically no cows in Canterbury to meet that limit, not a 20% reduction on the incredibly high level of pollution we have at the moment. So just to get across to you that what the government's talking about in the level of reduction is not even anywhere near, it's orders of magnitude away from how much change we need to make to protect those rivers and to protect human health. Or in reverse, that's how far we've gone. And I just wanted to throw this in here because it's really important to understand the economics of it as well, because it's something that I'm becoming more and more aware of as we look for solutions here. So this table here is not from my work. I mean, I've published a paper a few years back showing that if dairy in New Zealand had to pay its environmental costs, then it wouldn't be doing anything. It would be a nil-sum gain for the country. It only appears to be profitable for the country because we ignore the costs. But this is someone else's work. This is Warren Parker, who's now the chair of Landcorp New Zealand, our biggest farmer, chair of the board there. But he was at Scion at our forestry CRI when he did this work here. So basically what he's just looking at is a comparable size of central North Island to show the externalities of dairy in relation to forestry, pine forestry. And I'm not in any way trying to push pine as an alternative, but I just wanted to show you some of the numbers. So we're talking about 28,000 hectares of forest and 26,000 hectares of dairy, and everything here is per hectare. So, but it's just to give you an idea that it's a pretty sizable chunk of land that he made these comparisons on. So there's things like land value and profit and what's produced and unemployment, and the green stuff is the environmental impacts of it. And so what we're looking at is the externalities from those two land uses. And so what you can see is that if you look at the bottom line, the externalities there, it's $31 million for forestry. So forestry in that area is worth $31 million a year. And when it comes to dairy, it's minus $18 million a year is what it costs to have dairy in the central North Island in 26,000 hectares. And that was, if you look at the carbon price there, was at $7 a tonne. This was 2014, he did this comparison. So if you're looking at the carbon price today, then that would be more like minus $30 million for dairy in that central plateau. So to try and put some dollar values on that, which is what he's done here, he's used $400 a kilogram for the nitrogen leached price. And that is the amount, and that comes from what we paid. So there's two situations in New Zealand where we pay farmers not to farm to protect two lakes in New Zealand. It started with Lake Taupo, and now the most recent, well, in the last few years, has been Lake Rotorua. So we pay farmers. So the scientists work out how much nitrogen we need to reduce going into the lake per year. And so for the example of Lake Rotorua, it comes to 100 tons less nitrogen has to go into that lake to stop it from getting any worse. And if you do the sums on the amount going in there, that works out to what they're paying them is $40 million as a one-off payment to get cows off the land to protect that lake. So that's $400 per kilogram of nitrogen leached by those farmers is what we taxpayers are paying them to stop farming to protect those two lakes. Okay, that's fine, and I actually have to say that that's the only, there has been improvements, and it's the only example of an intervention that I have seen actually work at scale at reducing nitrogen loss is that example of Lake Taupo, and it's happening in Lake Rotorua as well. All of the other interventions are just fiddling, and you know, you might save a few percent being leached here, but then they'll put in a couple more farms, and so the net is actually a net increase in nitrogen. So that example there shows you that, you know, that's kind of, we're paying them not to do it. But what's so special about those two lakes? Why don't we apply that same logic to Canterbury, for example? And if we work out how much is lost from farms in Canterbury and into those rivers and lakes in Canterbury, then it comes to $12 billion we would have to pay to protect those waterways. If we took the same attitude we do to the two lakes in the North Island to the waterways in Canterbury, we would have to pay $12 billion. The big important thing, and I'll say it now in case I forget to say it later, is that that's a one-off $12 billion payment. You pay it, they get the cows off the land, end of story, do something else. And you've got to be careful, and we can talk about that if you like, because something else could be bad as well. But at the moment, what happens is they leach that much nitrogen every year. So it's $12 billion worth of harm, if you like, being done every year. Or another way of looking at it, it's a $12 billion subsidy being paid to farmers in Canterbury to allow them to keep on doing the harm that they're doing. But based on those prices we're paying for those North Island lakes, that's $12 billion. And if you look at nationally, it comes to $52 billion, the subsidy that we pay just to dairy to keep on doing what they're doing. And I've been working with a couple of researchers at Vic, looking at tax and a few other things as well to try and put some sums to this. So there you can see, I don't know if you can see my cursor, but we're looking at nitrate leached, and this is the data that comes from Ministry for the Environment, I think, for the year 2019. And then if you just look at the amount of nitrogen that's leached, and then pay, if it was paid out at that price that we pay in Taupo and Rotorua, then that's the amount. So effectively, we subsidize this harm done to our waterways to the tune of $79 billion a year by allowing that to happen. We also looked at emissions, and so I just did a quick calculation on the total emissions from agriculture per year from Ministry for the Environment on their lookup tables. And when I did this a month or something ago, the price of carbon was $74 a tonne. So I could see how much agriculture, if they were in the ETS and paying the full price, what they would have to pay. And that's where that $199 billion for agriculture. But, you know, try to be fair, I gave them all of the land use change and forestry. So all the sequestration for the country I gave to agriculture, and so I subtracted those two, and it still comes out to $902 million a year. Agriculture doesn't have to pay. So we give them a free ride, we let them, and they're not the only industry that's doing that under our ETS, but just to give you an idea of how much we subsidize farming in New Zealand, then there's $900 million there. Lisa, my researcher, Lisa Marriott at Victoria, OIA'd the tax department and got those numbers for the total tax revenue for the country, and then how much did agriculture pay as a percentage of that total tax. And you can see it's around 1.6 to 1.8% of the total tax paid in New Zealand is paid by agriculture. And you can pull dairy out of that as well. It was 0.7% of the total tax revenue for 2019-2020 year was paid by dairy in this country. So to me, and then there's a whole bunch of other things, that sort of subsidies and payments that are paid. But you can, just the point I'm trying to make here is how much we subsidize, you know, this industry that you'll hear them jump up and down. If there's any suggestions of subsidies overseas, that we are not subsidized. You know, the EU subsidizes farmers, but New Zealand farmers are not subsidized. These are all indirect subsidies to dairy, to agriculture in New Zealand. So to me, this is an example of the stupidity of our current food production system. So we have this situation with dairy where there's all those harms done by it that we don't charge them for, massive amounts of irrigation water to make the milk. And then we go and use coal to dry that water back out of the product. So we use a whole lot of water to make it, and then we use a whole lot of fossil fuels to take it out. They're totally dependent at the moment, this sort of industrial form of farming that we have here. Because the nitrogen fertilizer that drives those much unnaturally high stocking rates, a third of it coming from Kapuni and 2/3 from the Middle East. So using fossil gas to make nitrogen fertilizer, plus palm kernel from Indonesia, from that incredibly harmful production of palm oil overseas, the kernel, so one of the bits that's left over from that process. We are the biggest importer in the world of palm kernel, and we use it to feed cows here as well. So that's another way that we increase that intensity here. And then, of course, not only dependent on transporting all the stuff in from across the world, but then we export most of it back out again as milk powder. And of course, there's been lots of noise around this lately because of COVID and showing how the industry is dependent on desperate workers as well. So you have to have, New Zealanders mostly don't want to work on these farms, and they depend on bringing in workers from overseas. And then the argument, of course, is, but we're feeding the world. So aren't we feeding the world? Well, I don't think we are, because most of the product ends up either replacing breast milk or as a junk food filler. Most of it goes into this white powder that ends up as a coating on chippies and makes little Twinkie bars and all kinds of things like that. That's where most of it ends up. So I'll throw this back to you. Is that feeding the world, or is it making the world sick? And is replacing human breast milk feeding the world? That kind of stretches the definition, I think, but happy to be corrected on that. And I guess the thing that really makes me grumpy about this is that the only reason this industry exists is because we subsidize it by exempting them from having to pay for the harm. And what's worse even again than that is that then the more sustainable options, the other types of farming, don't have a chance because we prioritize and subsidize a harmful form of farming. Then if you want to compete with that, you can't, because the land prices are so high. Yeah, the land prices are artificially high because we subsidize the harmful processes that happen on that land. And that's an example of the fossil fuel input into the food that we're having at the moment. And those fossil fuels, we have to stop using them for climate reasons, but also that energy return on investment is reducing from 70. So 1 barrel of oil to get 70 barrels of oil when we, back in the early part of last century, and down to less than or around 15 now. So 1 barrel of oil to get 15 barrels now. So it's just a typical kind of curve where we take all the easy stuff first, and now we have to work harder and harder to get it. So more and more energy goes into getting energy, and I'll touch on this further on. But what happened is, once we started using fossil energy, fossils, to make fertilizer, then we initiated a massive population increase of humans and the animals that we eat, that we call the Green Revolution. And that's the kind of, the narrative is it's a green revolution that was kind of taught to me in high school as, or later on, as this really fantastic, the ingenuity of humans being able to make more and more food, despite all these Malthusian kind of predictions that we wouldn't be able to feed the world, that we're smarter than that, and we showed that we could produce more and more food. But there's nothing smart about it. All we did is just take energy from the past, solar energy basically, that was stored as fossil fuels from millennia, and started eating it out, which enabled a big population growth. And just to give you an idea of how much we have altered that cycle, the ratio of humans and our food animals and pets to wild animals is this shocking change now, where the wild animals on the planet are just a few percent of what they once were. And now, instead of there being mostly animal biomass and just a few humans, now it's mostly humans and the things we eat and just a few wild animals. And we've found really quickly, I've got my slide's a little bit out of order here, but this is just showing that, going back to the previous point before the animals one, about how much the human population growth is dependent on fertilizer here. So it's the fertilizer input increasing with population. So we could just feed more and more people. Once back in the 1930s, when we figured out how to turn this Haber-Bosch process to turn fossils into nitrogen fertilizer, then we started massively increasing the world population. So the world population is the black line, the top line there, and then the percentage of the world population fed by artificial nitrogen, just tracking up there with that dotted line. Meat production going up at the same time, so it enabled a huge number of more animals to be fed on the planet than whatever it was before. And the red dotted line there is the world population if we didn't have the Haber-Bosch process. If we didn't have the synthetic nitrogen, then the world population now would be just over 3 billion instead of the, what is it, 7.8 or something now. But on this graph here, sort of up around 7 billion. So half as many people on the planet if we weren't eating the past. And so just to give you an idea of, I'm sure you've seen this, the graph with the planetary boundary. So we've blown out the boundaries in the red on phosphorus and nitrogen and genetic diversity, in the yellow, so increasing risk for a whole bunch of things, land system change, climate change, freshwater use. We need to be inside that green circle to have a chance of a future. But what this graph shows is the black dots are the animals and the animal influence blowouts there. So a lot of the problems are being caused by the extra number of animals on the planet, which includes us. The food production is just more and more dependent on fossil fuels. So this kind of put things together. Agriculture, fishing, and forestry used in 1970, they used 43% of the fossil fuels, and up to 62% now. They cover 68% of the terrestrial surface of the planet. 22% of greenhouse gas emissions in 2010 were from animal agriculture. So they're really driving a whole bunch of these. Well, they're driving and they're part of our change in diets and that kind of thing as well. But it's about animals. And here is the graph I was going to refer to earlier. But there you have sort of before industrial humans, or going back in time, then humans didn't even show up on that plot in the tons of biomass. In 2015, you see that it's us and cows and the animals we eat that dominate the planetary biomass of animals. This little graph on the right here showing it as well. That's domestic livestock in the sort of pinky thing there, cattle, the darker red, humans, and the lower part of the triangle, the darker color, and then wild mammals at 2% down on the bottom left. And this, of course, even without climate change or anything like that, if you take over the planet with humans and the things that we eat, then you're going to have impacts on biodiversity as well. So you have this big shrinking invertebrate animal communities, animal populations declining all over the world. Lots of information around that, but humans are being impacted as well. So ecological threats, you know, in sub-Saharan Africa and places like that. So 6.4 billion people are living now in countries exposed to medium or high ecological threats. 2.6 billion of them living in the countries with extreme water stress. That is, they don't receive enough water to meet their needs. And even if we stay below 2 degrees increase, and this is out of the latest IPCC report, 3 billion people will suffer chronic water scarcity even if we can stay under 2 degrees. So that, you know, there's a whole bunch of these threats that are coming, and animals are a big part of that. But, you know, and again, it's not always that simple. 1 billion people are starving, you know, and 2.1 billion people at the other end of the scale are obese or overweight. And these highly processed foods that our dairy products are part of, high in refined sugar, fats, oils, and meats. We've got this food system that's utterly dependent on fossil fuels and not just fertilizer. If you look at the production system, you know, then you're looking at 10 to 33 units of fossil energy to get one back. And it all goes into the energy to plow, to plant, to fertilize, to harvest, to transport, refine, package, store, refrigerate, deliver to you, and then you put it in the oven or the fridge, or then you put, you know, there's just energy in. And plus the transporting of food around the globe as well. Just picked up a jar of peaches off the shelf, and it comes from, where was it? Oh God, I can't even think now. Somewhere in Europe. No, it was from Greece. Peaches from Greece in our supermarket shelves. More than 50% of the food we eat in this country is imported food. When it comes to just looking at fossil energy in the USA, and this is oil, straight from oil, 1 calorie uses 21 calories. So that is it's just completely reversed. The energy return. So that energy return on an energy invested the term was coined by a guy called Charlie Hall, a professor in the States, who was just coincidentally was working on fish migration for his PhD, the same as I was, and looking at this interesting dilemma of why do fish migrate? Why do they put so much effort into doing that? And he did the sums and figured out that, well, it was quite simple, because for every unit of energy they expended getting to this new biome, they got 14 back again. And so that's when he coined this term, energy return on investment. And it's the core of, we go out, you know, to get food, or an animal goes out into the environment looking for food, it has to get more energy back than it expends, or else it won't be around for much longer. You have to have a positive return on the energy that you invest in getting that food. But then when you look at those numbers, and then it's actually the reverse. It's somewhere between 20 and 30, minus 20 or 30 is the energy return on investment. It's just backward. It's just crazy. And this is something that I hadn't kind of thought about. Well, I hadn't related it to that energy input, but listening to Jason Bradford talk about this just the other day, what it allowed is a massive switch in the workforce from primary to tertiary, from what we would have done as hunters and gatherers of even in early agrarian societies, where most of the people were producing food. A smaller proportion were, you know, maybe working on that, processing it, you know, taking leather and making clothes and things out of it, and then a tiny number of tertiary kind of accountants or whatever. Now we have this utter reversal of that, and I've tried to show it with this graph here that I just made up. There aren't actually any real numbers in there, although I'm sure people could find them. Now we have these mostly tertiary, the lawyers, the property speculators, life coaches, baristas, you know, you name it. The tertiary proportion of the workforce is huge, and the number of people involved in actually producing the food are a tiny, tiny proportion. And that's an utter reversal of what would have been the situation, and that has enabled another consequence of that energy, food being made from energy stored in the past. So just to sum that up, that our global food system exceeds the biophysical limits. almost totally dependent on fossil fuels, harming the atmosphere, the water, and the land. And we're eating the past, energy loss rather than gain, which is just nuts. We can radically change our food systems, and I'll touch on that later. And we can possibly feed the current population with sustainable food systems. But what about the energy? What about the other part of it? We know everything that we look around, these machines that we're working on, we're all staring at these things that were made using fossil energy and run by fossil energy, or the infrastructure that's running them, if it's renewable energy, was made using fossil energy. Can we replace it and have this carbon-free energy so we can carry on doing what we're doing, and do we want to? So I wanted to touch on some in the last bit about some reality about decarbonisation. So pretty much this is how we have transitioned till now, from biomass to discovering fossil fuels like coal, starting off with the hard, with the coal that we could dig out of the ground, then moving into hydrocarbons with more and more energy density. So can we move from the world that we have now around us without fossil fuels that looks anything like we have today, is the question. And you need to understand power density for that. And I've just kind of put this density graph up here. This is, I mean, lots of people have worked on these things, but this has just come from, you can get the reference at the bottom there. But so across the x-axis is megajoules per kilogram, and on the y-axis megajoules per litre, so volume and weight. And you can see that those transport fuels, diesel, jet fuel, gas, the things, biodiesel, crude oil, the things that we can run cars and planes and things on, right up in that top blob there, incredibly energy dense. Look at batteries like lithium-ion batteries and lead acid batteries. They're right down the bottom end. They're barely showing up on that graph. And then you've got LNG and ethanol and those other things there, but crucially important to understand that big difference in energy density and the possibilities for the future, knowing that doesn't change. The blip that we're living through of having fossil energy from oil and gas is nothing can match the energy density of that. And if you look at things like biodiesel and vegetable oil up there, sure, they're up there with that same energy density, but if you looked at the energy return on investment for creating those things, then it's zilch. You'd be better off just burning. You'd use so much fossil fuel to grow and process the stuff to get it up there that you might as well just use the fossil fuels and save the land. So this transition, and this is really, really important. I don't know how many of you have really thought about this, or maybe you know this, but I'd say that most people in New Zealand have no idea that we actually have proportionally less renewable energy in our energy use now than at any time in the past. That we're not winning. We're not winning. There's lots more wind turbines, and there's lots more, solar panels and all of that kind of thing. But there's no reduction in the proportion. So as we put more of that stuff online, we just use more. We just add to our energy use. We haven't started. And if you really think about it logically, it's not going to turn until we start making renewable from renewable, because for each one of these renewable energy options, they require a whole lot of fossil fuels to be used. And so we're always going to be running behind. And then if you look at the costs, so when people say, oh, solar panels have never been so cheap, they're cheap because they're made from fossil fuels. Do the sums on what it would cost to make a solar panel out of renewable energy, and then see if they're cheap or not. And they're not. They're incredibly expensive. And so it's just part of the kind of game that we play with ourselves. I wanted to just give another reality check in. There's some great work that David Mackay's done. One really good way of a currency to compare, to understand energy use and options for renewable energy if you take how much energy a country consumes, and then you work out the area of the land. So, I mean, in this case, it averages out to about 5,000 watts per person. And then there's 250 people per square kilometre in the UK. You can easily calculate this figure here. So it's 1.25 watts per metre squared is the energy consumption of Britain, just for this thought experiment here. So what he then did was to work out what are the options for renewable energy production within Britain. So worked out how, if you put hydro wherever you could put hydro. This is just disregarding where cities and everything are, just taking the country as if it was no one was on it, and you could do all these things. Hydro, biofuel, wind, wherever you could put wind, and solar. And 4 watts per square meter. That need to understand that the solar panel might say it does 100 watts per square meter, but that's when the sun's on it. So of course it gets dark at night, so then you can halve that, and then it's cloudy some days, and so you take that off and you take that off, and then you get the actual what the solar panel can. So it goes from 100 watts to 4 watts, so about 4% of the rated value. And people kind of forget that. They think that you buy a solar panel and it produces at that rate 24 hours a day, and it doesn't. But anyway, what the big conundrum here is that when he put all those renewables together, the best he could produce in Britain was 1.25 watts per metre squared. So see the problem? It uses 1.25 watts. He could produce 1.25 watts. That means you would have to cover every square metre of Britain in solar, wind, biofuel, and hydro to be able to power the country at what it uses at the moment. And this is the best of all of these things, and this is being optimistic. So just puts into reality that kind of just how much you would need. And he did that for a whole bunch of countries in the world, and you can see that where they are on either side of that line. See where the United Kingdom is sort of smack bang in the middle here with Germany. So that means that you need to cover the whole country. Go out here to Singapore on the right hand side there, you need 60 Singapores to be able to produce the energy that Singapore uses. And go back out to the left hand side here to United States. You would need to cover half of continental United States to be able to power the total energy use of that country using renewables, notwithstanding the limits that I'll talk about on availability of materials and the concrete and the fossil fuels that you would need to build all the infrastructure to do this. This is just purely on the area that would be needed to do it, to give you a glimpse of reality of doing it. And then this report just came out the other day too. This is showing how much land you need to feed the United Kingdom. And so there's some interesting stuff there about, they've just kind of broken up the areas and stuck it onto the map there. And you can see beef and lamb pastures is the biggest green bit there, and cereals and built up area and dairy and all kinds of things. But the graphics on the right show how much extra land. So it's pretty much, you would need to double the size of the you need an area twice the size of the United Kingdom to feed the United Kingdom. So that kind of puts another restriction on the and this, I mean, of course, the thing to remember is this is based on current diets, and so it doesn't have to be that bad. This is almost the worst possible outcome scenario, because the shocking way that we do eat and waste food at the moment. But that just trying to give you some perspective on the amount of land that you need to feed a country. Okay, so then when it comes to thinking about this renewable energy and trying to power the world without carbon, got two things going on here. They're two triangles, and they're really, really important to understand. And the one on the left is showing the decline in energy return on investment. So, at the top there, the wide part of the triangle, you've got all the onshore, easy to extract liquid oil, where it basically bubbled up on the ground, from the ground. And then as you get into the harder and harder stuff as you go down, and you get into oil shale and tar sands and things, the energy return on investment is negligible. It's just not even worth doing. And that's we're well down that pyramid at the moment. Then there's a resource pyramid, which works in concert with that. And what it means is that all the easy stuff's gone, and copper's a really good example of that, where you start off with these really highly concentrated areas of copper, and the cutoff grade is 20% there. So the amount of material you have to move to find that much copper gets bigger and bigger and bigger all the time, because it's becoming rarer. You have to produce, you have to turn over and mine and process more and more material to get the same amount that you would have got from a much lesser concentration. So those two pyramids work in tandem to make it harder and harder and more expensive and more harmful to get the same amount of material than what you had before. And just those bottom two graphics, a high energy return on investments on energy invested society is the one on the left, and the arrow to look at is the blue arrow. So the red arrow is how much energy you have to reinvest back into getting the energy, and then the green arrow is how much you need for essentials. That could be food or whatever. But the thing to look at, going from a high energy return on investment society to a low one, which is the graph on the right, is that the blue arrow, which is your luxuries and your discretionary spending arrow, gets smaller and smaller. So it's pretty simple, really. The more energy you have to put into getting energy, the less you have available. And the simplification that I think sometimes helps explain this is, imagine you live, I don't know how far it is to Christchurch from Nelson, but I suspect it's about 300 kilometres. Say there was free petrol in Christchurch. You could jump in your car and you go and get this free petrol, but you've got nothing. You don't need to go to Christchurch. You go to Christchurch to fill your car up, and by the time you get back home again, you've used up all of the energy that you used going down there and coming back again, all the petrol. So it doesn't matter, price doesn't come into it. It doesn't matter that it's free petrol. It's still not worth getting, because the energy you have to expend to get it means that it's not worth anything. So that's kind of maybe another way of explaining how this works. And that energy return on investment, if we just look at oil there, and these little bubbles here are, so it's the amount of energy going across the x-axis, and the energy return on investment is on the y-axis there. So coal, for instance, there's a big range in the energy return on investment of coal, and how much is available to us is in the width of that bubble. So it's quite a bit of it. But you can see domestic oil in 1930 was right up there at 100 to 1. And by the time you got into the 70s, it's down to somewhere between 20 and 30. And now it's domestic oil today is right down there between sort of say 10 and 20. And so it's reducing all the time. And you can see those, the things I mentioned earlier, biodiesel and gasohol and tar sands right at that bottom end of that graph there. There's not much of them, and they're incredibly poor return on investment. And so this is the reality that we have to understand to get why we won't be able to do this miraculous transformation. This really busy graph here is just me kind of trying to put this all into one graph. But the key thing is the big red bubble in the middle, which is every one of these processes means that you need more energy. So this transitioning to renewables sounds fantastic. Build more Teslas, all of these electric vehicles, all of these kind of things, they need huge amounts more material and energy to be able to dig them up. Great figure that I saw the other day, one large offshore wind turbine, 67 tons of copper is required for the motor and the wiring to connect it up to the rest of the grid. 67 tons of copper requiring 50,000 tons of material to be processed to get that 67 tons of copper. And that's just for one wind turbine. And, you know, you start multiplying that out, and I'll touch on that again. But so that's why you need more and more. And then you need more minerals, and some of these are quite rare. And so you've got that problem of the resource pyramid for the minerals, that you have to process more and more of those minerals. Then you've got peak oil as well. So you've got less of this fossil fuel energy available to be able to build all of this stuff. Like there might be cut out for you, I don't know how much you can see, but those graphs up on the right there, the top right is that the consumption per capita of energy is increasing. The other graph with the green and orange and gray bars is the amount of material, the amount of material that's processed or mined, or not just for fossil fuels, but for everything. Just every year we dig up more and we waste more material. Per capita use of, and more and more of these gadgets that we have, and every room has a television and all of that kind of stuff, at least in the wealthy world. That food production that I mentioned earlier, all requiring more fossil fuels. So all of these things pushing into that central bubble there, we just need more and more energy. So we're going to become incredibly short of energy to be able to achieve any of these things that we require. Again, I don't know whether whether you can see this, but those and this is some work by Simon Michaud. But those little boxes up the top there that feed into energy and electricity, and make sure that you understand the difference between those. Remember that globally electricity is only about 20% of our total energy use. But then you've got oil, gas, coal, hydro, nuclear, wind, solar, and the size of the boxes pretty much relate to the proportions that are in our energy use at the moment. So we're gonna decarbonize. So bang, we've got to get rid of those fossil fuels there, and so that just leaves hydro, nuclear, wind, solar, and pretty much just the electricity side of it, not all the raw energy that's needed. And then again, I hope you can still see some of these things here, but we've pretty much dammed every river that can be dammed in the world. There's still a few more we could do. Nuclear is slow, it's expensive, and we haven't solved the waste issues with it. There's always promise of more to come, but there's been promise of more to come as long as I've been alive, and it hasn't happened. Wind is big. Installation, environmental and material footprints, like the 67 tons of copper for that wind turbine. Solar, huge material footprint, and it's intermittent as well as the wind. And they have short lifespans, you know, I mean, 20 years, 30 years, and you're going to have to replace them all. The battery metals needed to phase out fossil fuels. This is Simon Michaud's work here. Hopefully you'll have him if you haven't already. Talking about, so the blue bars are the global reserves of nickel, cobalt, and lithium, and the massive metal needed to manufacture the lithium-ion batteries to power the world. But he did this quick calculation. He is actually a miner. He's from the mining industry. He's a geologist. You would need to discover another basically 6 or 7 of the biggest known deposits of these things, and he'll tell you about how hit and miss it is, about how many mines never actually produce anything. So there's a huge amount of effort goes in and energy goes into these mines before they ever start producing, and very long lifespans as well. And the other thing that I really, and this has kind of slapped me in the face a year or so ago, when I thought about, also somebody does discover some magic free non-harm energy that comes from, I don't know, something we've never imagined before, and it turned up tomorrow. We had this amazing free energy. Would we actually be better off? And the more I think about it, the more I think, no, we would actually be worse off. I think the only thing that's going to save us from ourselves is running out of energy. Because if we have more energy, we're just going to keep doing more and more harm. We're going to fish out more oceans. We're going to dig up more stuff. We're like out of control kids. And there's the only way we're going to stop is if somebody takes stops us from doing it, and energy is the thing. So I don't know, you have to think about it. I certainly don't. There are issues around justice as well. I mean, I suspect that most of us watching this tonight are in that top part of this here, the richest 10% responsible for 49% of the harm that's done. So what we need to do in New Zealand now, just touch on that before I finish up. We need to establish a full emissions profile, and I don't just mean atmospheric emissions, I mean like nitrogen as well, of agriculture and horticulture. And we must apply the full cost to the industry that's causing the harm. We can't allow this exemption, these externalities to be unpaid for as they are at the moment. And that would level the playing field. And then we don't have to subsidize regenerative farming or better farming practice. It's not a matter of needing to subsidize them. We need to stop subsidizing the bad stuff, because, you know, look at those numbers that I showed earlier on. We are letting the agriculture, especially dairy industry in New Zealand, off on almost every single cost. They don't pay tax. They don't pay for their nitrogen impacts. They don't pay for their atmospheric impacts. They don't have to pay for their fresh water impacts. If we stopped that handout to them, then you'd be nuts to carry on making milk. You'd go and do something else. We need to start thinking about the true value of food systems when it comes to nutrition and human health. And this is touching on that junk food milk powder thing that I was talking about. Our current system doesn't differentiate that. We just call everything food, right? Whether it's junk food or really good quality protein, we just pile it all as food. And until we start differentiating that, I don't think we're going to get far either. The new food systems will have to be local. They have to have no external inputs, no palm kernel, no fossil fuel derived fertilizer, no emissions to atmosphere. No monocultures will be crucial to that. And they, of course, must be positive on their energy return on investment, because otherwise, why do it? If you're putting more energy into getting than what you get out of it, then you won't be doing it. It's just nuts. And so, you know, we have plenty of examples of where much better food production can be done. I mean, they're very small examples at the moment, but it's because in all of these places they're up against a subsidized, harmful industry. And our landscapes changing our landscapes in New Zealand to away from monocultures and away from this industrial farming would give us so many opportunities for reinstating rural communities and economies, as well as, you know, all sorts of potential for people wanting to be on the land rather than not wanting to be there. So this is some of David Hall's graphics here, but what we have now is a conservation estate, we have exotic forests, and we have pasture and agriculture, and we separate these things off. And in the future, they're going to have to all be together. I want to see where we don't have a dairy farm or a sheep and beef farm. We have farms that have everything happening on them. They have some cows, they have bees, they have trees, they have permaculture at multiple levels. There's so, you know, and there'll be so much nicer places to be than these monocultures that we have at the moment, where you have to find desperate workers from overseas to work in them because it's back-breaking work, and it's hard work because you're in the middle of just a paddock of thousands of whatever it is, or an orchard full of thousands of the same thing. And they're not nice places to be. The changes would make them much nicer places to be. This is David Hall's work. Just another reality check here, and this is a pretty harsh one, but it kind of gets the point across about the radical change that we need to make. So if you work out the world's energy consumption and convert it all to megatons of oil, of fossil fuel, so megatons of oil equivalent, we call it. So in 2018, we used about over 11,000 megatons. It turns out we have about 11,000 days to 2050 when we have to get rid of fossil fuels. This is simplistic, but just to put it into perspective. So that's a nice little combination there. 11,000 megatons, 11,000 days. So we have to replace 1 megaton every day from now until 2050 to be able to be carbon zero by 2050. So we'd need to build to kind of put that into reality every single day. And we needed to start 4 years ago, was to build 1,500 big wind turbines every day for the next 11,000 days to 2050. And I just did a conservative estimate there. That's covering about 777 square kilometers each day. And this is for the planet, or one large nuclear power plant every day for the next 11,000 days as well. At the moment, there are 432 last count, 430 nuclear power plants in the world, and the last one took a couple of decades to finish. So just that's the kind of reality on what we need to do to reach this magic carbon zero. We need to be aware that we're dependent for everything that we take advantage, well, almost everything we take for granted comes from fossil fuels, and we have to reduce at least 10% per annum what we're doing. And so we have to face the reality that those changes predicted by the limits to growth, which are all about to plateau now and start to flip the other way, are here. And we either manage our way out of our growth dependency voluntarily, or we face catastrophic change. And it's going to come in all sorts of forms. And what's happening in the Ukraine is part of the kind of future that we have if we don't do anything about it, if we just let business as usual carry on. And I wanted to make it clear that I'm not anti-renewable energy, or I'm not anti-trees, or I'm not anti-electric vehicles. I'm anti the hype that's around these. So this idea that we just have to convert to electric vehicles and we'll all be all right is completely and utterly wrong. And I have nothing against trees. I love trees. The only tree that is a bad tree is a tree that's planted as an excuse or as an offset to enable fossil fuels to be burnt. So if you think that you can go fly somewhere and it's all right because you plant a tree, you couldn't be more wrong, because what you're burning in that plane flying around is not from the current carbon cycle. It's from a carbon cycle that's at least 80 million years ago. And so what you burn, what that tree sequesters, is from today's carbon cycle. So if you replanted every tree and reinstated every wetland on the planet, all you would do is balance up what the trees that got chopped down and the wetlands that got drained and all that kind of thing. You haven't accounted for a single gram of fossil carbon. And so that's where this offsetting is not just delusional, it is dangerous, because while we play that game in New Zealand, and James Shaw's part of this, is this offsetting, bullshitting ourselves game, where you plant something or you sequester something somewhere else. It's not from the same carbon cycles. It does not account for it, and we should not allow ourselves to be kidded by that. And we need to face that reality. And as long as you put that idea in people's minds that they can offset what they're doing, then they will offset it and they won't stop flying. And so we will get nowhere while we kid ourselves with that kind of delusion. We need to face the reality that this is a blip like no other blip, and we're up there where that star is somewhere in that consumption of energy, and there's nothing to replace it. And so we have to figure out how to live without that. So we need to end the self-delusion, the net zero, carbon zero, tree planting self-delusion, the delusion of, and you know, it's sad but true that the IPCC have relied so much on things like carbon sequestration and storage, things that are utterly impossible. There's this idea out there that we can decouple emissions from GDP, and yet that there is no facts behind that. Countries that look like they're decoupling their emissions from GDP are simply exporting their emissions to some other place. And, you know, like, buy your EV in New Zealand or buy a car in New Zealand, the emissions got loaded onto the country that built that car and you bring it in here thinking that you're doing somebody a favor, and you're not, because you're not paying the true cost of that. We don't, part of this whole self-delusion is, for example, military emissions are not included in any of our accounting. So we just pretend they don't happen. That is just classic human self-delusion. So we need to bring in reality, and we could do this in a lot of ways, but consumption-based accounting of greenhouse gas emissions, I think, is really, really important, so that some kind of trade so I mentioned here energy quotas. I mean, Jack Santa Barbara's talked about this. He knows more about it than I do, but some way of accounting so that we get a budget, a bit like a wartime ration card, maybe, of how much carbon or embodied emissions that we can individually have, and we can trade them. And so if you don't use them, you can get something for them. But it has to be based on what the planet can handle, and how most people live, especially in the wealthier parts of the world, we would blow that in the first couple of days of the year, the way we live at the moment. But I want to see the emissions loaded onto every product. So a new Toyota, four-wheel drive, if the emissions were loaded onto it, not onto the country, but onto the vehicle, and at today's carbon prices, I haven't worked it out, but it would probably be at least $100,000 to buy that vehicle if the emissions were loaded onto it. And then you wouldn't get people all going and buying these things. So I think that's definitely something. It's just like the dairy industry having to pay for its impacts. All of us have to pay for our impacts, and no loading the externalities onto other countries or any of the games that we play at the moment. The remaining carbon budget that we have, and we know how much carbon we can burn or we release into the atmosphere to stay under, we're probably past it, but say we can keep it under a level that'll make a livable planet. We know how much that is. None of that should be spent on going skiing or on holidays, or it should all be used to build the kind of infrastructure that we're going to need to survive without fossil fuels and with the impacts of climate change that are coming. It's that kind of reality it's tough, but it's the only kind of way we're going to have a future. And I think that Edward Wilson kind of nailed it here. The reason that we probably won't do that, or we struggle to do that, is that we have Paleolithic emotions, medieval institutions, and godlike technology. And I think that's so true. But also that we won't change things until we face that reality. And I really want to make sure that we try to not be taken in by those delusionary things that are being offered, sort of pretending that we can kind of plant trees to get our way out of this, or carry on living like we are, and not face that reality. Okay, that's me. I've had my rant. Happy to answer some questions now. I'll stop the share.
Mike, thank you very much, and everyone. Was iconoclastic maybe the right for this man? That was a very, very rich feast for us, and I think that people will probably be grateful to go to the recording of this, to really study some of those graphs and take in that material. And we're getting messages from people like Rachel Sanson to say, amazing, Mike, thank you, and Lindsay Wood expressing his gratitude. Let's go to the questions, and we'll do our best to get through them to give everybody a chance. Thank you for this, says Emily Moon, very powerful and seated in reality. Okay, Viv Williams would like to know what happened in 1990 that all this pollution increased from that period in New Zealand?
Yeah, well, what happened was this, and a lot of it's because the measurement started then, but what happened, and I don't know how old Viv is or how old the people are. I guess that some of you are as old as I am, but will remember Think Big. So in the 1980s or 70s and 80s, I think it wasn't Shell BP Todd, it was Shell Oil Company. One of the big international oil companies offered to prospect for gas off our coast, and they did a deal with the New Zealand government with Muldoon was the Prime Minister then, and they found oil and they would bring it ashore, but there was a take or pay scheme. And so some of you, I'm sure, will be familiar with this, but a take or pay scheme in this case meant we're going to take this gas out of the ground and we're going to give it to you at this rate. And if you don't use it, you're going to pay for it anyway. And it was a very high rate. To make it worthwhile for them to dig the holes, to set up the offshore pipelines and bring it ashore, they wanted to sell a huge amount of it. So then New Zealand government was left with this dilemma of, okay, we've got to come up, we want this gas, but we're going to have to come up with some way of using all this gas. And so at a high rate. So that's when this Think Big project started in New Zealand. And so up until 90s, one of they came up with a whole lot of schemes. There was a gas to gasoline plant, a methanol plant, but the big plant at Kapuni was to turn that gas into nitrogen, to ammonia, nitrogen fertilizer. So they set up the Kapuni plant. And so up until that time, it was nitrogen fertilizer was not used. Synthetic nitrogen was not used in farming in New Zealand. And we had a very vibrant dairy industry at that time. And we fixed nitrogen naturally using clover. The paddocks were full of clover. Clover fixed the nitrogen and made it available to the other plants, and the grass grew using natural systems of nitrogen sequestration. Then you had this Kapuni plant set up and excess amounts of nitrogen and fertilizer companies. So we then suddenly start giving all of that, had to create a use for that nitrogen fertilizer. And so around the 90s was when huge change happened, where farms in New Zealand suddenly started using nitrogen fertilizer, and it's an addictive process. Ask anybody who's used it or tries to get off it, that once you add synthetic nitrogen, the clover then doesn't have the competitive advantage in the paddock, because it doesn't have that advantage of being the plant that fixes nitrogen. So therefore it has it available. So it disappears, and the soil chemistry changes. And so you become dependent on nitrogen fertilizer then, and you'll certainly get a boost in production at certain times of the year. Back in the day, a lot of the researchers called it the bank manager's fertilizer, because you could boost production at certain times of the year when normally it would have dropped off. And so back to Viv's question, that's when it changed, was when suddenly you had a huge fertilizer company, fertilizer co-op set up, and they pushed this product, and New Zealand farmers grabbed it and ran with it. And so you had the massive intensification that happened as a result of taking what was a very valuable resource with the gas off Taranaki and having to use it in a big fat hurry, and so creating this system.
Thank you, Mike. Sean Kavanagh says, Kia ora, Mike, what are your thoughts about criminalising environmental destruction, ecocide, by amendment of the Rome Statute to make this the 5th crime against peace at the International Criminal Court?
Yeah, okay, I think that sounds fantastic. I've become aware through decades of making a noise that I make no difference at all, but where we do have wins is in court. And so I'm a great fan of legal processes as being a way to get change, and I hope that so I see that ecocide, if we can kind of make that happen, then and actually you know, maybe make CEOs responsible or something like that, then yeah, I mean, I would love to see some of the people in some of the related industries in New Zealand being prosecuted for the harm that they do. You know, so yep, I think it's a great idea, and I'm hopeful that that will make a difference.
Thank you. An anonymous attendee says, what's the difference between a regular dairy farmer and industrial?
It's those inputs. If you look at the stocking rates that we had before we started bringing in synthetic nitrogen and palm kernel and that kind of thing. I mean, I was dairy farming back in the 80s, and we would have maximum, we might have approached 1.5 cows per acre, and mostly less than that, and sorry, per hectare. And now it's closer to 3 to 4. Places like really intensively palm farm parts of New Zealand are over 4 cows per hectare, and so that's the difference. It's industrial is when it's reliant on external inputs.
Right. Here's a somewhat complex question from Molly Mellish.
Mm-hmm.
Tiny forests containing all species in the local climax forest are planted at 3 stems per hectare, forcing them to grow tall. They present 30 times as much leaf area to the sunshine compared to lawns. Suppose we found browsers instead of grazers, roe deer, possums, goats are too hard to confine, instead of cows. Could the yield of meat and milk equal or exceed that of conventional farmed livestock? Could the resulting wood production exceed that of pine plantation?
Okay. Hi, Molly. She's one of my heroes is Molly. Yeah, I mean, I think she touches on a really important thing here, but I did want to, you know, just remind Molly and others that we're not producing food. You know, like, so what if what we did with dairy in New Zealand was to make cheese and butter and milk, then I don't think I would have such a problem, and we could, you know, the production would be measurable as a valuable thing. But when you use coal to dry it and turn it into junk food, then you really degrade the production of what comes off of it. So Molly's talking about a much simpler system where we're just producing meat. And yes, I suspect that, well, I don't have the figures in front of me, but it's logical that if you produce, you know, as an ecologist, it makes sense that over multiple levels, you know, that basically, you know, pasture farming is a single one-dimensional form of farming, whereas trees are multi-dimensional, and you have a lot more ability to capture sunlight, to photosynthesize, and to feed and produce more at multiple layers than you do at a single layer. So, which is what I think that Molly's touching on. So that would be part of that dramatic alteration of food production, would be at multiple levels and not just growing grass to grow animals.
Thank you. Matthias Otto comments that the spectre of free, non-harming energy became a little closer last week in the report of progress with nuclear fusion. And he adds the comment, I hope not.
Yeah, yeah. Well, if he's anything like me, he's heard that same story for 50 years now, that it's just around the corner, and maybe it is, but yeah, we're in trouble if it is, because it'll just enable us to do more harm than what we do now. So yeah.
Right. Lindsay Wood, after thanking you and saying it's a brilliant talk, says, is it out of the question that, say, PVs might be able to produce enough energy to make more PVs and have some left over?
Oh, I don't think it's out of the question, but it would be incredibly expensive, and that's the thing. You know, you do the sums on, and especially each generation, it gets harder. So the first generation of solar panels making, the next generation, the first generation were made from fossil fuels, so they were cheap, so they could make the next lot cheaper. But then each cycle you get into that, it just goes exponentially more expensive to do it. And you've got to mine all those materials and do all that kind of thing as well using electricity. So yeah, I just can't see it ever possibly being able to scale up, because the energy return on the energy invested, by the time you factor in all of that processing and production and the end of life, having to deal with the end of life part of it, would just push it beyond any sensible future, I think.
So Molly Mellish isn't daunted. She's totally with the flow of this and says,
Good.
bring back the Carboniferous and Mesolithic lifestyles.
Yes. I think, yeah, no, she's right. Yeah, I agree.
Pascal Delos says, how do we stop these businesses offering to offset your carbon emissions, like Air New Zealand and rental companies, making business on the back of environmental honesty?
Well, that's capitalism for you, isn't it? I mean, that becomes a bigger question then, where that is the business model. Is they want, you're getting the same bullshit happening with oil and gas promoting hydrogen. They do not want the public to know the reality. They'll destroy their business if the public knows the reality. Air New Zealand wouldn't have a hope if people realise the harm that was being done and that it's not being offset. So they have to keep. And in a way, I'm not that. It's the same with the dairy industry. I'm not angry with the farmers in any way. I feel they're trapped in the system. I get more angry with the people who cover up, the people who work in government and regional council, local government, who cover up the reality and are part of playing the game. And the same with the trees for flights. I kind of just accept that Air New Zealand's going to play that game like any business would, but when politicians start backing them up on that stuff, I get angry with the politicians, because they know better, and so that, and they're not dependent on it. So yeah, but yeah, that's capitalism for you, isn't it? They're always going to try and make a profit from everything that they do.
Mike Finlayson says, the reality is we have to live with 10% of the energy we're currently using. How do we do this?
Well, I mean, all I can say is that in my lifetime, I've doubled my energy use. When I look back to, when I was a young man, and I can find the figures for this, I didn't have a laptop, I didn't have a cell phone, I didn't have all of this crap that I see around me in my office here. The car might have been less efficient that I drove around in, but it didn't do as many miles because I spent half my life working on it. And life with half of the energy use we have at the moment, just speaking personally, was a good life. Somehow we convince ourselves that we have to have all this crap around us, and I've just, having come back from a month on a 90-year-old wooden boat sailing around the Sounds in Nelson, I living on a little bottle of LPG, and my experience of a couple of months in the subantarctic islands with virtually no energy at all, I don't really think I swallow that whole thing that we need all that energy. I've visited places. I did a sabbatical in Romania and spent some time up in the mountains with people whose lifestyles are virtually unchanged in thousands of years, and they don't need energy. They don't need money. They don't, it's kind of like all the things that we think are so important. I don't know. I think, I guess that, your people can come back with, well, but what about that, life-saving operation and all of those kind of things, which you can't kind of argue with. But a hell of a lot of the energy use is utterly unnecessary, kind of stuff that we'd be a lot better off without. So yeah, that's about all I can say. I know it's all we've ever known is this fossil fuel driven world, and so it's very hard for us to imagine a life not like that. But you only have to look to see how other people live in other parts of the world, and they can get by with a hell of a lot less and still have amazing lives.
Okay, here's one of us, an anonymous person who's upset at what he or she has heard, saying this is not just self-delusion, it's how our brain works. I wish more than anything we could include human behavior in these things. Humans aren't essentially evil or bad. I'm really, really cross with this narrative.
I agree. I don't think that we're essentially bad. We're just lazy, and we'll always take the easy way out. You know, I'm not implying that people are bad. I'm just being realistic. That's what we do. I'm not. That's just observation. You can see that's what we do. If there's an easy way, we'll take it. If there's a shortcut, we'll take it. If you can give someone an electric scooter, they'll jump on it and ride all around the place rather than walk, you know, or electric bike or whatever it is. Well, electric tools, you know, power this, power that, all the things that we used to do by hand that we use machinery for now, that's just the reality of humans, that's what we'll do. I'm not saying I'm not having a go at humans for that. I am a human, and I know that I will do that as well.
Pascal Delos says, I heard on the French radio today someone advocating a big push to redevelop nuclear energy, which doesn't mean refusing degrowth. In order to not depend on other countries and stop fossil fuels. He was claiming the dangers were very limited compared to other causes of death and injuries.
Yeah, no, I'm not anti-nuclear. I know how hard. There's actually a French nuclear power plant's the most recent one that took over 20 years to build. Just the reality of how long it takes to build them, and remember that it's only electricity. There are so many. You can't fly planes with it. Well, you can fly planes short distances. You can't fly long distance with electricity. You can't. You know, you can have limited thing. You know, electricity is great at running computers and heating and cooling and that kind of thing, but there is a whole bunch of things that electricity can't do that we take for granted. So sure, you can make up some of it with nuclear, and it will definitely be part of the future, but you know, it doesn't solve any of the other issues that we were talking about.
Matthias Otto wants to comment on consumption-based accounting. And says, shouldn't the countries we sell our agricultural products to pay for our farmers' emissions? That'd change the playing field somewhat.
Yes, yeah, for sure. That would be the case, and it would have to go both ways. But you know, as long as we pay for the emissions on the things we import, and I suspect we would just come out even when we did that, because we pretty much import as much as we export. And maybe the emissions would be a lot higher on the high-techy things that we import.
Charlotte Brewer says, do you think transitions to permaculture and regenerative agriculture would be enough to bring the dairy industry into balance with planetary boundaries? I'll
just come back to what I said. If we stop subsidizing industrial dairy the way we do it, then the only logical alternative is regenerative farming, and so you don't have to do anything to make it happen. And it might not produce enough of the stuff to want to dry it with coal. You know, I mean, depends, you know, how far you go with this, because we could easily feed New Zealand, you know, with you know, some tiny proportion of the land that we have at the moment. I mean, most of what we produce on all those dairy farms with all that harm is milk powder that goes to replace breast milk, and you know, made into infant formula, and most of it just goes to junk food. So much of that harm that's done is done for a very low value, no value product, and it's only because we can. That doesn't mean that it's right. We can and we do.
Philippa Newton asks, what impact do you think a vegan lifestyle would make?
Oh, I think that there's definitely, huge environmental advantages in getting away from animals and animal products. But there is a place, undoubtedly, there is a place. I don't want to completely write off animals, and I totally understand and accept the vegans' choices, and I hate harm being done to animals, and I hate seeing the way that animals are treated on farms and all that kind of thing. But there are situations on small holdings and things where a single cow is much loved by the people there and can provide and can keep its calf, doesn't have to have taken off it, and can provide milk for the family and neighbors and all that kind of thing. And so animals don't have to be badly treated, and they can be a very important part of cycling nutrients and that kind of thing. So veganism for those who choose it, and less meat or no meat is definitely better for the planet. If we're talking about the kind of industrial production of it that happens for most of the wealthier people in the world. So I don't know if that answers it. I don't want to. I'm not anti-vegan or anything like that. I just don't. I don't want to go to that full extreme. It doesn't suit for all situations.
John Paul Pochin asks, given the size of the problem we face and the enormous changes we need to make in a very short time, there's a danger that we see the problem as too big, so we do nothing. What's the point? How do we challenge that thinking, and how do you keep going?
Yeah, well, I don't know how I keep going, but that is the enormity of the problem is a massive challenge, and Joanna, you understand this as much as anybody. Personally, and I think everybody's different on how they handle it. I think there are, in my experiences, that there are very few people who can take on the reality, and we have defense mechanisms for it. And I was on a Zoom call with a bunch of people in this space last night trying to find ways around it, and everybody had their opportunity to talk about it, what they do. And one familiar theme that came up throughout it, because my example of what I do is this old boat, and how, well, there's a whole lot of things in relation to that, but the common thread was doing something that concentrates your mind. So for me, sailing, especially when it's a bit wild and it's a bit rough and things are going on, that you have to switch off from all of this stuff just to concentrate on what you're doing. A couple of the people on the call they had no idea that they had this in common, but they were into archery, and they didn't say they were particularly good at it, but the concentration. And another one was juggling, doing juggling 3 or 4 balls, and just that kind of headspace you have to go into to concentrate on something like that frees up your mind, and they found that really, really powerful. So I think that it's very individual, but for me it's the boat and the sailing, and doing things that actually have an end point and you can see a result for, like doing some work on the boat and being able to see that I've achieved something is a really big one for me, because most of the stuff that I'm doing, I see no outcome at the end to kind of feel satisfied about. So that I really crave that kind of thing.
Yeah, I'd like people to just note Mike's answer to that, because lots of listeners are really passionate activists and work very hard at it. And I think your method of keeping going is really worth noting. So Lindsay Wood says, financing of dairy setups creates huge debt for for farmers. How do you think we might find a manageable pathway for farmers to escape from that instead of being driven to keep dairying to meet debts?
Yeah, well, I mean, that sort of comes back to my example of paying those farmers to not do it, and how, you know, we've got that example now. It's happened in 2 lakes in New Zealand, and, you know, there's a total of $130 million that's been paid out. That, I think, as far as I can see, is the only way out of it, is that you can't, unless somebody's going to go and forgive all that debt, which is very unlikely because they're not New Zealand banks that the money's owed to. So I think that, and, you know, I don't know and how this would work. I know that, for example, through this COVID crisis, that a whole lot of money was created in that process. And so I suspect that you can create some money to do this, but I feel so passionately that a one-off payment to stop something bad, because the people that are involved in it now, most of them went into it quite innocently, not knowing that they were part of a system that does so much harm, because that reality is kept from them so well by big business that they're involved in. It's unfair for them to go bankrupt and into huge amounts of debt because they went into it not knowing. And so it's up to the rest of society to pay to stop them doing that. And man, I never would have thought I would say this, but we have the precedent now, and we should carry on doing that, because it's so much cheaper for us as a society in the long run to bite the bullet and pay out so that that harm doesn't continue, than to let it continue and let future generations pay for it, and human health issues and all that kind of thing. So, I mean, we just have to look at Christchurch, just to give you an idea, and I didn't include this, but that Christchurch City Council recently were involved in a plan change, and they paid a consultant to calculate what it would cost just for the Christchurch City alone to get that nitrate out of the drinking water. And it came to $1.8 billion and that was the cheaper option. The other option was to pipe it from the upper Waimakariri River, which would be $2 billion to do that. You know, this is just to put that reality on how we subsidize one industry by the harm that it does to the public. So privatized profit for a few versus public cost for many. And so why would be so much better off paying off? So back to Lindsay's example, then those farmers would have their debt written off by the payment. They'd be paid to change what they're doing. Well, not paid to change what they're doing, paid to get those harmful practices off their land.
Robin Treadwell says, thanks for presenting such a dire situation so clearly, Mike. Do you have any comments on how to tell the truth to the public and on the Eat Lancet planetary diet, healthy for people and planet? Thank you.
Yeah, I know there's, you know, to go along with that Eat Lancet, there is a New Zealand study that out of Otago University just in the last couple of years, I can't think of the title, but it's publicly available, where they've done a similar process for New Zealand, and the eat healthy means a hell of a lot less meat in your diet and that kind of thing. And I think that that's really, really crucial. The question about how to get the truth and reality out is, I don't know the answer, because people don't want to know, you know, and it's just human nature again that you don't want to know about this stuff because it's all too much to handle when you've got a whole lot of other bad things happening in your life at the same time. You know, that's COVID's really taken our eye off the climate change ball, I think, and other impacts, because we get caught up in the immediate problems. And so yeah, I don't know. I think that's a question for the psychologists, is how we get that truth out. Yeah, that's your job, Joanna.
Quickly go on to Fiona Edie. Not only are we seriously harming our waterways and environment by our intensive agriculture, but we're mining our soils. Our soils are in danger of collapsing if we don't start to look after them. How do we get people to value soil?
Yeah, well, I mean, that's all part of that same picture, isn't it? And it's that loss of connection, farmers becoming industrialists, you know, and with high debt levels and all that kind of thing. That association with understanding their farms and the soil has kind of disappeared, and they become these managers of you know, multi-million-dollar industries with lots of pressure from the outside. There's a lot. I know there are, you know, there's a lot more talk and a lot more understanding about the importance of soils, and I think it kind of goes hand in hand with the freshwater stuff that, and the greenhouse gases. So the kind of de-intensification that we need to make in agriculture will help with the soils, the atmosphere, and the water. And so it's you know, the greenhouse gas emissions, the whole, if we could just stop siloing into, you know, I just see endless examples from government of talking about greenhouse gas emissions of some particular thing, and not, so you have the Climate Commission, you have, you know, the separation into different departments, and the same within universities where, you know, the climate change people are in one place and the soil people are somewhere miles away, and they're just not looking at the combined gains that can be had from de-intensification that go across all of these issues. And while we keep concentrating on them individually and not seeing the bigger picture, it means that we won't get there. If we think about soils and atmosphere and water and all of these things together, then we will get somewhere.
We have not too much time left, so I'm going to select a few questions, and particularly this one from a young person. Hiya, Mike. Thanks so much for sharing. As a 22-year-old student who feels very passionately about these issues, what is some advice you would give your 22-year-old self to help us have a more hopeful future?
Oh, well, I mean, that's interesting, because I actually feel more hopeful when I talk to young people that they do understand these issues and that they are willing and aware and will make the changes. God, I mean, me at 22 would have been a hopeless case to talk to. I was a petrol head who drove around in noisy cars and was just a real little shit. And I really am amazed about the young people today, how much more aware they are and how much less like I was at that age. So yeah, I don't know. It's a really, really tough one to be thrown in at your age into a world that's in a state that it is. And yeah, I would be really angry. And I just think that the more that you can do where you're involved in doing something, like as soon as you're doing something about it, then it becomes much less of an issue. It's when you feel helpless and you feel like it's just going to happen to you, then it's a horrible situation. But once you get involved, and clearly you are, because you're here tonight and you're listening to this, and so you're doing stuff, and just keep doing that is the way. And I wish that when I was 22, I was listening to things like this and onto it, instead of being a petrol head.
Matthias Otto says, I keep hearing the story that New Zealand is producing agricultural products with the lowest carbon footprint of all countries. Is this true?
No, it's not. And we've found the fault in that paper. So this is Dairy New Zealand running around telling everybody this, and the minister believes it and everything as well. But if you go on to the website, who is it? I can't even think who. I know Stuart Ledgard was one of the authors, might be on Landcare. Anyway, the calculations, and they didn't even admit to it except in a footnote, that when they used the IPCC calculations, we come out about middle of the countries in the world. It was just they used a different calculation system, and when they re-corrected the paper, they didn't mention it to anybody. They just updated the paper and left it with the same title on the web page. And you have to, I mean, if he contacts me, email me, I can give you the actual the link to the changes and highlight the bits where they have redacted what they said before. But we're middle of the pack basically of the countries that are in that study on greenhouse gas emissions per unit of production.
That's pretty interesting. Here is the last question. You might like it. Mike, you mentioned capitalism in your answer to my question. Isn't degrowth necessarily dependent on questioning capitalism, human greed, human warfare, on working on a different set of values worldwide, on being political?
Oh, for sure. Yeah, all those things. I mean, we seem to, every time you talk about capitalism, people go, oh, well, what did you have communism? As if there's only two possibilities in the world, you know, and they just use some poor example of a misapplied alternative. I don't think that, you know, for a second that there's only two ways you can do something. There must be a better way, and capitalism, for all its good things, has definitely got a whole lot of bad things, and this growth dependency is clearly suicidal, and we need to face that and sort of not get stuck in this left right communism, capitalism, democracy, whatever kind of endless arguments. We have to rethink how we live, and that growth can't be a part of it.
Okay, I'll end with a comment from Lindsay Wood, not a question. Lindsay says, Mike, you're a legend. Thank you so much. Your voice is incredibly important, even if you think court cases seem more important, more effective.
Yeah.
So I want to endorse that and salute your generosity, Mike. Well, far more than that, but your generosity in hanging out with us here in the top of the South for 2 hours, enlightening us, and has an endorsement of the Euro legend, Mike. Great talk, and so on. It has been a very important talk for us, Mike. Thank you, and I think there are going to be a lot of hits on our website to go over the very rich material that you provided for us. Tons for us to think through. So thanks a million, Mike. Thank you very much indeed.
Thanks, Joanna. Thanks to you guys on the forum, because it's really important that these, you know, things happen, that these opportunities come to kind of discuss this kind of reality. I think it's a really, really good way of doing it. Thanks.
Great. And thanks everyone for being here. Lots to think about, lots to work through and translate into our climate work. So we hope to see you all again before long. Thanks all. And to Marlene and Christina for doing the tech stuff.
Okay, tell them to stop recording.